All right, so as you can see there, what we're doing first is we're going to graph just a quick review one of 3 cosine of x. So how does cosine start? What's that? Yep, we're going to start at its highest value here because cosine either starts at its highest or its lowest value, and it's always whatever's out in front. So cosine at 0 is going to be up at 3. At 90, where are we going to be at? We're going to be at 0. At 180, we'll be at its lowest point. And then 270, we bounce back up to 0. And then 360, we're back up at 3. All right, and then we do the best we can to just draw in our graph here. Do remember that at 3 and -3, those are your highest and lowest points. So make sure your lines don't go past that, don't go above that or below that. Make sure the arrows are starting to point back down, that sort of thing. All right, so any questions with that? All right, we've got 2 different shifts to deal with today. All right, here is one of them. For this one, we have y equals 2 sine of x plus 45. All right, now this is one of those that I would do in 2 parts. I wouldn't try and graph the whole thing at one time. Most of the time it doesn't work very well. So I would kind of break this into parts here. The first thing that I would do is I would actually ignore this plus 45 for now. We'll deal with that later, but I would want to graph out this 2 sine of x here. All right, now similarly to the cosine one that we just did, this 2 represents our highest point. Because it's positive, we're going to go up right away, but for sine, we start at 0. So our first point is there at 0, 0. At 90, we're going to be up to 2. At 180, we bounce back down to 0. At 270, we're down at -2. And at 360, we're at 0. All right. Any questions if it was 2 sine of x? All right. Now, I would put that, I wouldn't draw in the line here, but I'd at least put those points down. So then when we come back and deal with this here, we can just shift those individual points. Okay. Now, we go back and we use this plus 45 here. All right. Now, one of the rules math-wise is when you're trying to figure out what the shifts are going to be here is if it's inside parentheses, you want to switch the sign there. All right, so this becomes a -45, and all that means for each one of these 5 blue dots here is we are going to shift them 45 degrees to the left. Okay, so this first one, for example, if we shifted it 45 degrees to the left, it would fall off the graph. So I'm going to ignore that one. This top one, though, this one's at 90. If we shift it to the left 45, there's a point. Okay, so every single one of these other ones, we're just going to shift to the left 45 degrees here. All right, and then we can start to draw in the line for in between those points. All right, so it's going to look something similar to that. All right, now remember, one of the rules that I have for you is I want to see at least 360 degrees of your graph. Okay, so for this top part up here, we know that it's going to start to come down. It's not going to get all the way down to 0 though. So we're just going to bring it down a little ways here. How we know that it doesn't get back down to 0 is for this graph, there would have to be 180 degrees in between each one of the zeros. So it's going to start to come down. It's just not going to get all the way down to 0. 0 would be kind of maybe right about there. Okay. On the other side, it's the same concept. We're not going to get all the way up to 2, but we're going to be heading that way. All right. So there would be an example of what the graph looks like. Now, if you want to, all right, the graph paper that I have is always between 0 and 360. If you wanted to expand your graph, that's totally fine. I wouldn't be upset with that at all. It just depends on you. I just want to have at least 360 degrees there. All right, so any questions there? I would put the blue dots in there just as a starting point. It's kind of like with an algebraic problem, you showing your work. All right, that's one way to kind of get yourself on the right track, and then you shift them, and then you draw the line in. All right, next one, we've got y equals -6 plus sine of x plus 90. What does that -6 stand for out in front? What was that, Chase? Yeah, we're going to go down 6, and that's where our middle line is going to be. So if you wanted to, we could reassign this x-axis as just a -6 here. All right, we know our a value, our amplitude is going to be a 1, so it's going to go up to -5 and down to -7. Okay, or you could just shift everything down 6. It all depends on you. I think this is normally a little bit easier to deal with, though. Okay, so we dealt with the -6. We don't have to deal with that anymore. Okay, really quick, I'm going to graph out this part of sine, and then we'll shift everything. So sine x from there, just like we were talking about before, starts at 0. And 90, we're up at its highest value. 180, we're at 0. 270, we're at its lowest value. And 360, we're back to 0. Okay, so that would be our first step then. Then to come through and actually shift this. Remember, it's inside parentheses. So we're going to switch the sign here. It means we're going to shift all 5 of those points to the left 90 degrees. So first one's going to fall off. Second one, we shift it to the left 90, we're at 0. 180 goes to 90. 270 goes to 180. And 360 goes to 270. If you follow the pattern that works for this, where are we going to be at 360? We're going to be right back up here. Okay, it just so happens to work out that every 3 boxes here, we're shifting between our top value, our middle, and our bottom value. So we'd have another 3 boxes here to be at our top value. And then we just draw in the graph. All right, and that would be for that entire equation then. All right, so you can still kind of break this up into parts. For some of our graphs that we've had in the past, you're not able to do that nearly as well. For sine and cosine graphs, it's a little bit easier to do that with. All right, so we shifted it down, we shifted it right and left. All right, we have one more thing to deal with here. All right, so we've got y equals 10 plus sine of 4x. The one kind of shift that we have not done yet is we have not dealt with any number that's out in front of x yet. Okay, and we're going to leave that until the very end, just like we did before. So I'm just going to ignore that 4 for now. All right, the 10 becomes our middle number. And then our amplitude here is 1. So we're going to be up to 11 and down to 9. And then this one just says sine of x. So start at 0, 90, 180, 270, and 360. All right, now at this point, what I would do, if there was another shift on here, I would shift all 5 of those points first before I deal with this 4. Okay, we don't have that, so we can go ahead and deal with this, this 4 here. All right, and what this 4 happens to deal with is this deals with the frequency of the graph. All right, and really what it tells you is how long a wavelength is. Okay, if you look at our sine graph here, it starts at 0, it ends at 0. This would be one entire wavelength. So that would be 360 degrees. And if you think about our normal graph here, or our normal equation, we've always had a 1 out in front of this x. So we would divide by 1. And that's how we know that it's 360 degrees. All right, for this one though, we have a 4. All right, so to tell how long our wavelength is going to be, we take 360 degrees again and just divide it by 4. So then one of these waves is not going to be 360 anymore, it's going to be 90 degrees. Okay, so how do we deal with that with each one of these points here? All right, for each one of these points, we just look at the degree measurements and we divide them by 4. So for this one here, 0 divided by 4, that just stays as a 0. For this one up here, 90 divided by 4 is 22.5. So we're going to be right about there. All right, our next one at 180. 180 divided by 4 is 45. And notice I'm not changing the y values at all. Those always stay the same. We're just shrinking our x values. For 270, we divide that by 4. I believe that's 67.5. So it's going to be right there. And then 360 divided by 4 is 90. All right, so if you look at this, there is one condensed wavelength there. Okay, now the annoying part of these is this 4 also tells us how many wavelength or how many waves we're going to have in 360 degrees. Okay, so we're going to have to put all of those there. Okay, so for our next spot, we came over just under a full box and went up 1. So there's that one. The next one is in between the next 2 boxes. The next one is at the beginning of the next box. And then 180, we're at 0. All right, and we just keep working with that pattern here to be able to get all of the rest of the points that we need for this graph. Right, and there would be our sine graph shifted up 10 units that has been condensed by a factor of 4. All right, so that's kind of the route that we need to go to be able to get these taken care of. Okay, I don't think the numbers get too terribly big here. I know last year when we did it in Algebra 2, they asked you to do like a 7 or a 10 or something like that, and that's quite obnoxious. I don't think this book gets quite that extreme, okay? Now, one thing to realize though, is say that instead of this being a 4x, say that this is a 1/2 x. Well, what this means is you would only have half of a wavelength here, okay? So if sine is normally, it goes up to the top, back to the middle, and then down, and then back to the middle, you'd only have half of that. So you'd only have the top half of that wavelength. Okay, so instead of dividing all of these blue dots by 4, you would actually multiply by whatever this is here. All right. Any questions at all? All right. We're going to go to the next one then. All right. Last lesson for the week. Okay. Lesson 58, we are going to be talking about the distance from a point to a line. And then we're going to talk a little bit about parabolas and how we're going to do it in here is different than the book. So just keep that in mind as you're going through this. All right, so as you guys can see there, it says find the distance between the point, -3, 5, and the line y equals 1/2 x plus 1. All right, now what's going to happen for this one, and you do not have to graph this out, but I'm just going to show it to you visually here. All right, we're going to have a line for this, and then we're going to have a point off the line in some way. Sometimes it's going to be really close, sometimes it's going to be a long ways away. All right, this question, even though it doesn't state it very well, is always asking what is the shortest distance between that point and the line. All right, and for us to be able to find that, we need to find that distance there. All right, what do you see between the two lines here? They are what kind of lines? They're perpendicular lines. Okay, so what we're going to have to do, all we know is one point on this line. We're going to have to find the equation of this line given what we know. All right, so like I said, you don't have to graph it. That's just what we're doing here. All right, so to find this perpendicular slope of this line, we know the other line is y equals 1/2 x plus 1. What's the perpendicular slope going to be? -2. Yep, we're doing the negative reciprocal of it. So we know our slope. We also know a point that's on that line. We can use point slope form to at least get the equation of this new line here. So we have y minus 5 equals -2 times x plus 3. All right, so we have our one line, we have our other line. We need to find another point on this line. And the easiest point to find is going to be where these two lines intersect. Okay, so that's where we would go back and use substitution, elimination, Kramer's rule, any of those. Most of the time, my guess is going to be that substitution is the easiest way to go. All right, and what I would do first here with our equation that we already have is I would set this equal to y. All right, so y minus 5 equals -2x minus 6, and then I'd add the 5 over. And when we do that, we have two equations that are set equal to y. So then we can set them equal to each other. Right? And then we can just solve for x. We've got one equation with one variable. We can just solve for that. So I'm going to add the 2x over. I'm going to subtract the 1. So I've got 2.5x equals 2. All right, so then we just have to divide by that 2.5. And when we get an answer for this, The book a lot of the times leaves these as fractions. It's not necessary to leave them as fractions. If you want to change it to decimal, go right ahead. But 2 divided by 2.5 is 0.8. All right, so we've got that one. How are we going to find our y value? Yeah, we're going to plug it back into either one of the equations. I'm going to plug it into this one down here. All right, so y equals, this would be a negative 1.6 minus 1. Looks like we get a, did I do something wrong here? This should be a negative 2, good call. Yeah, this should be a negative 0.8. That would make this a positive 1.6 and y equals 0.6. Thank you. I knew this answer was wrong, but I didn't know where I screwed up at. All right, so any questions getting to that point? All right, so then what we know, guys, if we look back at our little graph over here on the side, we know our 1 point, we know another point on that line. We have to find the distance between them. All right, so we just do our distance formula using those 2 points. All right, so we would have negative 3 minus negative 0.8 squared plus 5 minus 0.6 squared. And then we're going to take the square root of all that. Okay, and for something like that, just throw it in the calculator. It's fine. And I got an answer of 4.92 units. They don't tell us what the units are, so 4.92 units there. All right, so for this, all right, honestly, there's nothing new there. It's just putting a lot of the stuff together that you guys have learned in the past. All right, we're coming up with a perpendicular line. That was our first group of steps here. Then we did substitution to be able to find where the two lines intersect. And then after we find the second point, then we did the distance formula between those 2 points to get our answer. Okay, so what I want you to do here is I want you to go ahead and try this one. All right, find the distance from -1, 5 to the line y equals 1/3 x plus 4. And so remember, first step is to find your perpendicular slope, and then to find the new equation with your point. Any questions with what you see up there compared to what you did? All right, so like I said before, lots of steps here. First thing, you got to find your perpendicular slope. Then you find the equation of the perpendicular line that goes through the point that you're given here. All right, so I'd throw it into slope-intercept or point-slope form, and then I'd change it to slope-intercept form. So then I can do a quick substitution here. Solve for x. Then to solve for y, you plug your x back into either one of the equations. You pick and choose which is easiest for you. It doesn't matter. And then once we find our point, we've got our new point and our old point. We just got to find the distance between them. So we're using the distance formula to get there. All right. Like I said before, in the answer key, I think a lot of them, they leave as exact values. Just grab your calculator to see if your rounded answer is equal to their exact values. It's not a big deal if you reduce it or simplify it here to a decimal. All right, any questions at all before we move on? Okay, lots of steps, but you guys can do this. All right, for the next one, they say they want us to complete the square to graph the parabola. I wouldn't do it either. All right, it is a lot of extra work that you don't necessarily need to do. Because the question truly is, they want us to graph the parabola. It doesn't matter how we get that graphed. So think back to steps that we've had to do in the past to figure out how to graph the parabola. What's it got to be set equal to first? Yeah, it's going to be set equal to y. It's never set equal to 0. So for this equation here, before we set it equal to y, I'm going to solve it for 3y. So we're going to move everything to the other side. And then we have to divide everything by 3 here. So we get a 1/3 x squared minus 2/3 x minus 5/3. Okay. Now, at this point, you could complete the square, but it's already got fractions in there. My biggest complaint with completing the square is you almost immediately start with fractions and you don't ever get rid of them. So why would I want to do that if there's an easier way to go? All right, and I've always thought the easier way to go is let's just find our vertex. What's the equation to find the x value of your vertex? Good. All right, and remember our a value is out in front of our x squared, so it's 1/3, and our b value is in front of our x, so it's negative 2/3 here. All right, and we just plug those in, and for this one, a lot of stuff simplifies out here when we throw this in, because we get a positive 2/3 on the top, and then 2 times 1/3 here is 2/3, so our x value is a 1. All right, and then we just got to figure out what our y value is. And just like before, we just plug that in to get that. So 1 squared is 1 times 1/3 is 1/3. Minus 2/3 would be a negative 1/3. Minus 5/3 would be negative 6/3, which is the same as negative 2. So what we're doing here is we did it another way so that the fractions wouldn't get worse, and actually we eliminated the fractions here because our vertex is going to be at the whole numbers 1, negative 2. All right, so then we just need to get a couple more points on this graph and we can call this one good. Normally, we have an a value of 1, and when we have an a value of 1, it's always up or over 1 up 1. Or if it was 2, it was over 1 up 2. Our a value is 1/3 here. What do you think you can do? That's right. Yep. Instead of just going over 1, up 1, we're going to go over 3 and up 1. And the same thing with going back. We're going to go back 3 and up 1. And technically, once you have those 2 points, that's really all you need to be able to draw this parabola in here. All right, and we do know this is going up because our A value is positive. So that's all the further we have to go here. All right, this one's going to be wider than some of the ones that we've done in the past. Whenever your A value is between 0 and 1, it's going to be a wider parabola. The bigger your A value gets, the narrower it gets. All right, so if this A value was like a 20, it'd almost be going straight up and down here. Okay, so any questions on this? Do we need to complete the square to do it? Just ignore it. It's not worth the time. The only thing that completing the square does is it helps you get your vertex. This seems like a pretty easy way to get your vertex too. Okay, so keep that in mind. All right, so we're not going to do this next one, but walk me through the steps. All right, so take a look at that one. Y plus 2x squared plus 12x plus 17 equals 0. What would you do first? Solve for y. Yep, after you solve for y, what do you find? Vertex. All right, once you find the vertex, then we're going to have a pattern. This is going to be a -2 for an A value. So then we just go over 1, down 2 in each direction, and then we're good to go. All right, so completing the square doesn't necessarily help you much in getting this one done quickly. All right, and like I said before, it just helps you find your vertex, which we can find it using -b over 2a. All right, so any questions here for me? All right, so homework. You're not going to have a quiz on this one because, and we're not going to have a quiz on Wednesday either next week. I'll give you a break for that one. I'll give you a break on this one because hopefully, if everything goes well, your test will be next week, Friday. I sent out the lesson numbers for you already. So your homework is just any 25 questions from lessons 57 and 58. All right. I would probably spend a little bit of time looking over stuff this weekend just to see what trouble areas you might have on those lesson numbers that I sent out. You don't necessarily have to spend a ton of time studying for it right now, but it might be good to figure out what